Okay, looking at the definitions of length and distance, and we'll be looking into angle later on. And let's say that, okay, just fresh off of looking at inner product, okay, let's say that we have vectors u and v to be in an inner product space V. And now for the length or norm of u, okay, its magnitude is going to be equal to the square root of the inner product of u and u. And we have the distance between u and v is going to be the norm of the difference between u and v. And now, as a sample of looking at finding inner product, length, and distance, okay, first of all, we have for given vectors u and v, if we find the inner product as well as the magnitude or norm of u as well as that of v, and the distance between u and v for the given inner product defined on Rn. Again, we have in this sample, say we have from number 19, so we have u to consist of the components -4 and 3, so we'll designate those as u sub 1, u sub 2, and v we have with 0 and 5, which we will respectively have to represent v sub 1 and v sub 2, and we have for the inner product of u and v, so we have 3 times u sub 1, v sub 1 plus u sub 2, v sub 2, and for what we have for the inner product of u and v, and using the formula, okay, so we have 3 times -4 times 0, and for u sub 2, v sub 2, we have 3 and 5, multiplying those together, so we're going to have 0 plus 15 equal to 15. So we have for part A in this problem, we have the inner product of u and v to be equal to 15. Now for the magnitude or norm of u, that is going to be the square root of the inner product of u and itself. And if we go ahead and arrive at the inner product of u and u, okay, so you have u sub 1, u sub 2, v sub 1, v sub 2 from the algorithm, but again, we have for u and itself, okay, so in lieu of just taking we have from the components of v, we just duplicate what we have with u. So we have -4 and 3 to occupy both what is otherwise the u sub 1, u sub 2, v sub 1, v sub 2 components from where we had with the function regarding the inner product of u and v. And so we have in the follow through, okay, we're going to have 3 times -4 times -4, and we have plus 3 times itself, and we have with the products, we have 48 and 9, whereupon we had the sum to come out to 57, and we had the norm of u is equal to the square root of that product space, and so that will come out to the square root of 57. Now for the norm of v, we're looking at the square root of the inner product of v and v, and so we have for the inner product, okay, so we have this time we have duplicate pairings with 0 and 5, and following through in accordance. Okay, so we're going to have 3 times 0 times 0 plus 5 times 5, so that will come out to 25. And we had the norm of v to be equal to the square root of 25, which is equal to 5. Now, for the distance between u and v, again, that's going to be the norm of the difference between u and v, and that's going to be the square root of the inner product of u minus v with itself. And for u minus v and itself, now the inner product, so we have the u sub 1, u sub 2, v sub 1, v sub 2 pairings, we're just going to have the duplication of the v sub 1, v sub 2 to occupy both spaces of what we have from the inner product definition of the function of the inner space we have with u and v rather. Okay, so we have u sub 1, u sub 2, v sub 1, v sub 2. We have 4, -2, 4, -2, and then following through, so we have 3 times -4 times -4 plus -2 times -2, and we have 48 plus 4, which is equal to 52. And for the distance between u and v, that is going to be the square root of 52. And breaking it down, and we have for the reduced exact radical form, we have the square root of 4 times the square root of 13, and the final outcome we have a 2 times the square root of 13. And if we have, let's say in number 26, for the same 4 items, And we have for u, again, we have the components where we have 1, negative 1, 2, and 0, and we'll have that to represent everything from u sub 1 to u sub 4. And v, we had the components with 2, 1, 0, and negative 1, and we'll have those to represent what we have for v sub 1 to v sub 4. And for the inner product of u and v, that's going to be the dot product of u and v. So we have for u dot v, have u sub 1, v sub 1, u sub 2, v sub 2, u sub 3, v sub 3, all the way out to u sub 4, v sub 4. And for what we have with the components and putting in the specified values, okay, so we have 1 times 2. For the first pairing, second, we have negative 1 times 1. Third pairing, we have 2 times 0. And the last, we have 0 times negative 1. And for the products, we have 2 and negative 1, 0 and 0. And that combination for what we have in the inner product for u and v, that is equal to 1. And for the norm of u, so we're looking at the square root of the inner product of u and u. And so we have with the duplication of u sub 1 through u sub 4, okay, representing, okay, v sub 1 to v sub 4, and applying the dot product with u and itself. Okay, so you got 1 times 1 plus negative 1 times itself plus 2 times itself plus 0 times itself, so that comes out to 6. And so the norm of u is equal to the square root of 6. And for the norm of v, we're looking at the square root of the inner product of v with itself. So putting v sub 1 through v sub 4 and duplicating and having that to also be put in for what we had originally to be u sub 1 to u sub 4 from what we had with the inner product of u and v, but now replacing that u with v. And we have for the dot products, okay, so we got 4 and 1, 0 and 1, and that outcome is also at 6. And for the norm of v, that is equal to the square root of 6. And for the distance between u and v, we're looking at the norm of u minus v, and that is equal to the square root of the inner product of u minus v and itself. And for u minus v, okay, so we have taking the difference between the components, and we have from u, we have 1, negative 1, 2, 0, and v, we have 2, 1, 0, negative 1. And for the difference, we come out to negative 1, negative 2, 2, and 1. And for what we have for the inner product, okay, so we're looking at taking the dot product of what we have with the duplication of u minus v. So you have negative 1, negative 2, 2, and 1 will represent respectively both u sub 1 to u sub 4 as well as v sub 1 to v sub 4. And we have with the respective dot products, so we have 1 plus 4 plus 4 plus 1 is equal to 10. And we have for the distance between u and v, again, that's going to be the norm of u minus v. And in effect, we had the square root of 10.